A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Our today's talk will be Module 11, where we will discuss some of the pavement distresses and their possible causes, along with the what kind of treatments can be taken when these distresses occur on bituminous or flexible pavements. So, at the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, in the previous lecture, we have discussed about the different type of pavement distresses, which were clubbed under 4 main different headings. Here, I will pick up those distresses, will discuss the possible causes and what can be a good say or what is a usual treatment which is applicable when these kind of distresses occurs on a flexible pavement. So, starting with, as we discussed in the previous lecture, bituminous or flexible pavements, like any engineered structure, undergo a wear and tear with time in due course of its life. So, therefore, prone to various kind of distresses which takes place. It may be deformation may be there, some cracking may be there, some loss of material may be there. So, these kind of distresses, like any other engineered material, can happen with these flexible or bituminous pavements also. And these signs of distresses, some fine cracks are there, some loss of fine materials is there, may not be an alarming one unless they occur prematurely in the early years of the life of that particular pavement. Then, so premature distresses are the major concern for engineer. Distresses develop because it is expected, it is an engineered structure which is subjected to different environmental conditions, traffic loading during its course of service. So, it is expected that when they approach their near the design life, because of the traffic loading and the environmental conditions, some distresses are prone to occur. But if they occur prematurely in early years of life, that is again a major concern for the pavement engineers. Surface distresses may arise from multiple underlying causes. This is one important aspect, because the manifestations on the top of the surface which is visible to the user and to the engineers may be because of causes which may be lying hidden in the underlying layers. So, surface distresses may arise from multiple underlying causes. Therefore, it is important to carefully or properly identify those causes. That is important part, and then on the basis of that, corrective measures are to be suggested, because if the correct cause is not figured it out, then there are chances that it may reoccur. So, that is why it is always important to investigate properly, so as to find out for this particular cause, because a single distress may have multiple causes. We will discuss those ones. So, in that case we have to figure it out, and what can be a possible remedial measure which will be best for that kind of distress occurring because of one particular reason or a combination of reasons. In other words, for any remedial measure to be effective and to last long, the cause of the problem must be first determined and then addressed. But always it is important that during the planning stage, during the design stage, during the construction stage, the control has to be more at those different aspects, because it is very difficult at a later stage to do that investigation to work out the individual causes. We will see into these discussions. So, bituminous pavements experience various kind of distresses which we discussed here in the previous lecture over their service life, and in some cases they may occur prematurely. So, that is so even when we occur at say a later stage of life also, then also some treatment has to be done, so as to increase to keep the serviceability to a desired level and to increase the service life of the pavement. So, the following points highlight the common causes that often lead to the development of some such distresses. One is, if we are selecting poor quality of materials, then you can observe premature distresses. the poor quality of materials may be your aggregates, and the poor quality may be in terms of the shape of the aggregates, maybe the strength of the aggregates, maybe the gradation of those aggregates. And in case of say binding material like bitumen, it may be a wrong grade of it may be a binder which is more susceptible towards aging, it may be a binder which is very stiff. So, these needs to be properly investigated before being used. So, if poor quality materials are used, substandard materials are used, then definitely we expect one or the other kind of distress to occur. And even with good quality materials, if the construction is not done properly, if the construction practices which are mentioned, which are clearly specified by our specifications are not followed, we can't expect a good quality of finished product. Deficiencies in asphalt mix design, as we know, bituminous mix, the bituminous bound mixes are the mixes which provides very significant structure strength to a flexible pavement structure. So, there if the design is not done properly in terms of the computation of the volumetric properties, in terms of the estimation of the mechanical strength properties, in terms of the estimation of the optimum binder content, then we can expect different kind of distresses taking place, that too prematurely. Insufficient pavement structure thickness, this is again, if we are whatever the thickness which has been designed, if the same has not been provided, it has been compromised, whatever granular course is, whatever the bituminous bound course is, if their thickness is compromised, definitely it will lead to premature distresses. The other concern is traffic volumes exceeding the design estimates. Usually, you design the roads for a period of 15 to 20 years of life. So, you are estimating the traffic which is going to come in those 20 years of life. So, that if that the design or the estimate is not correct, if the traffic volume is more than whatever you are considering, then your pavement structure is going to show some distresses. And the other part is, usually when we compute these design traffic, we take care of the axle loading which is actually happening. So, during the computation of the design traffic, we compute a factor which is known as vehicle damage factor. So, that takes care of the axle loadings of different axle combinations which are there. If that is not properly done, we may encounter traffic which is having higher axle loads compared to what has been considered during the design. So, then your structure strength may not be inadequate to carry that particular loads. So, again it will show some signs of distresses. Excessive aging of asphalt binders, certain binders are more prone to aging, but if you have ensured it through the required specifications of binder, but then also during the construction, if these asphalt pavements are constructed with high amount of air void contents, as we see when we construct a bituminous mat, we usually target for dense graded one 6 to 8% of air void content, which is then expected to come up in the range of 3 to 5% after say initial years of traffic, that is secondary compaction in 2 to 3 years of life. But if we compact it, if it is not properly compacted, the air voids are more than that 6 to 8%, maybe 10-12% more than that, then those high air void contents leads to excessive aging of the binder. So, then binder becomes stiff and then it is prone to distresses. Higher variation of temperature and rainfall, this is again a common concern, because you pick up your binders considering what is the range of temperature where this particular mix has to perform. So, if that is not properly considered, you might have chosen a softer binder or you might have chosen a stiffer binder than actually desired. And the rainfall estimates have to be proper so as to design for the surface drainage in a proper manner. Lack of some preventive maintenance jobs, some regular routine maintenance has to be carried out and some preventive maintenance activities has to be carried out. In the next lecture, where we will discuss those maintenance activities specifically and what treatments are there and the general treatments where we will discuss. So, those say cleaning of your drains have to be there, maintenance of your shoulders have to be there. These exercise needs to be done regularly so that to ensure uniform performance throughout the design life of that particular structure. So, these are some of the common causes because of which one or the other distress takes place in the flexible pavements. Now, in the previous lecture we discussed the different distresses. Today we will discuss the causes and what usual treatments which are suggested for those different type of distresses. So, we discussed about the surface defects in the previous lecture, where fatty surfaces, bleeding, smooth surfaces, streaking, hungry surface was discussed. Then cracks under cracking distress, hairline cracks, alligator cracks, edge cracks, shrinkage cracks and reflection cracks are there. So, deformation, rutting, corrugations, shoving was there, shallow depressions is there, settlements and uphills were there. Then disintegration is there, where stripping, loss of aggregates, raveling, potholes, these are the different distresses which are usually grouped under these 4 different heads. Now, we will discuss some of these distresses and the possible causes, along with what can be a treatment which can be applied for these distresses. So, coming to the surface defects, one of the common which we discussed was the bleeding, which usually occurs under hot weather conditions when the bituminous binder, which after filling the whatever voids which are there in the bituminous mat, comes over the top of the compacted layer, migrates upward under traffic and forms a surface film. So, this is you can see this is a sign of this bleeding which is there. So, this process is not reversible, because if the temperature goes down, it does not goes inside it. So, it is not reversible during cold weather, resulting this binder remains on the surface itself, and then the surface becomes, we can call it fatty, slippery and skid prone. So, if presence of water is there over this particular one, it becomes a sticky as well as slippery surface. Now, what could be the possible causes of this kind of binder which has come over the top of your bituminous surface? One is excessive binder which has been in the mix. So, while designing the mix, you have designed the mix in an improper manner to a higher binder content than what is required for that particular one. So, that excess binder has come up on the top, or the quality control was not there, because you have designed it, but while constructing or while producing at your hot mix plant specifically, that control was not proper. So, the mix was ultimately produced at higher binder content than what was designed earlier. Low air void content of the mix, as I mentioned, that we expect to have around 3 to 5% after say secondary compaction of 2 to 3 years, and just after rolling we expect to have a air void content in the range of around say 6 to 8% for dense graded mixes. Now, if they are over compacted during rolling operations and then during secondary compaction they get compacted to air voids less than say 2%, then in those cases the chances are that under the traffic loading the mix will rut and the binder will come up on the surface, the binder will be squeezed on your asphalt surface. So, that is another case when you have lower air void contents. Use of softer grade of binder. So, as we mentioned, depending upon how much is the traffic loading and the temperature range in which it has to perform, we have to pick up a grade. If a softer grade is picked up, then also this binder may be pushed under the traffic loading to the top surface. Over application of tack coat is there. Whenever we construct any bituminous course, the existing surface a tack coat is to be applied, but if it is not properly applied through the bitumen distributors, excess quantity of tack coat is applied, then it migrates under the traffic loading to the surface, and we can see these kind of the streaking is also observed, or we can see this bleeding in that case if localized spots are there. Loss of cover aggregates in case of surface dressing, as we discussed when we discussed about surface dressing, that a bituminous film is to be applied, and thereafter we go for the application of the key aggregates. So, adequate quantity of the bitumen is to be applied, and then the key aggregates need to be embedded inside it. So, if excess quantity of bitumen will be there, then this will have the distress of bleeding. So, this is a specific case when surface dressing is there, or even we can have this when the aggregates are not properly, the key aggregates are not properly spread, or more or less there are flaky and elongated aggregates are there. So, they lie flat and they go inside the bituminous one. So, in that particular case again you may have these surfaces where excess bitumen is there on the top. So, bleeding may occur. Now, depending upon what is the severity level of the bleeding, the different type of typical maintenance measures or treatments are suggested. One says if it's a low severity bleeding is there, then it can be treated by applying a heated coarse sand, because we need to pick up specifically what the excess binder is there on the top. So, we will go for an application of a heated coarse sand, typically the one which passes 1.18 mmHg to absorb this excess bitumen. It is a heated one, and a small rolling is done over it. So, this is when you have these small spots are there. So, this you can go. So, a low severity bleeding is there. If it is a medium severity bleeding is there, or fatty surfaces are there, then they can be corrected. What we can do, as we have the application of some chips may be there, pre-coated chips may be there, specifically the one which we used in case of surface dressing also. So, the one passing 4.75 mm here and retained over 1.18, and pre-coated means we can go by coating them for 1% of bitumen, and we need to give them the due time for the when these pre-coated chips are used, and then they can be. So, these pre-coated chips can be spread over the, you can see the pre-coated, these chips are getting spread, these are uncoated ones, we can go for pre-coated ones depending upon our requirement, followed by a light rolling which is there, so as to allow them to sit inside this excess bitumen. High severity bleeding is there. If this bleeding is very severe, then it is preferred to mill out that particular one. We can scrap out that particular portion where it has shown an excessive sign of bleeding, and we can reuse that material, or we can put up a new layer of it, of a mix over it. And in that particular case, we can even go for a application of a slurry seal or microsurfacing. And even for large fatty or irregular areas, the affected area can be completely removed. This is, and then you can go for a properly designed new mix. So, even milling can be done for a localized portion. If there are this bleeding is extensive for those particular areas, we can put up a new mix, and then on the top we can go for surface this slurry seal or microsurfacing. We will discuss these later on when we will discuss the general treatments about the bituminous mixes. Another defect which is there under the surface defect is a smooth surface, that is the skid resistance of the surface is getting reduced, or the frictional resistance of the surface gets reduced, and this is typically related to the characteristics of your aggregates, where you use aggregates which are more susceptible towards polishing. We have already a polished stone value which needs to be ensured when an aggregate is to be used in a surface course. But then also if this kind of distress occurs because of any reason, then one of the, as mentioned, one of the main primary cause of a smooth pavement surface is aggregate polishing. It polishes prematurely under the traffic, and as we discussed during the measurement or evaluation of skid resistance, two factors usually play important role in terms of the pavement surface characteristics. One is the micro texture, which is quite related with the aggregate property. It is aggregate rugosity or the roughness of an aggregate particle, and the second is the macro texture, which is the mixed characteristics. The gradation of the mix is the one which affects your macro texture. So, if you have inadequate micro texture as well as macro texture, so that will lead to a reduced skid resistance. So, your micro texture can get reduced along with your macro texture in due course of time. So, in that case you will have a lower skid resistance. And the other part, if the binder is excessive, you have designed, there is no bleeding, but in such the binder is excess, so you may not have that much of macro texture available with us. So, that will also lead to a reduced skid resistance. So, if these are the cases, then the best part is we prefer to go for a thin surface application in the form of, it can be surface dressing may be there, slurry seal may be there, or micro surfacing, or even we can go for a dedicated course. If we desired very high friction resistance, it is open graded friction course can be there. So, these are typical courses which can be applied over a surface to enhance its skid resistance. But again, it is important whatever aggregates we are selecting for the surface dressing also, for our open graded friction courses also, we need to ensure that they have a good polishing resistance. So, this is again an important aspect. With this one, or even if required, because if you are going to go for a new asphalt mix also, definitely that one also is going to give us a better frictional or skid resistance compared to one which has already been subjected to wear and tear by the traffic. So, these are some typical measures which are treatments which are taken up for the cases where you find a smooth surface. Now, the other is streaking is there. This is again distress which comes under the surface defects, and specifically they are observed longitudinal streaking are there. We can have transverse streaking also, but most commonly we observe longitudinal streaking. So, what we see during these streaks, alternate strips of pavement surface which receives uneven quantities of bitumen. So, you can say at certain portions you will find the binder is appearing more compared to the remaining part of the carriageway. So, that means it is a non-uniform application has been there. So, what are there? Usually they have mechanical faults are there, especially with your bitumen distributors are there, improper adjustment or careless operation of bitumen distributors. So, this bitumen distributors specifically when you go for say application of your prime coat or an application of your tack coat, then this is an important part. So, streaking may also result from spraying binder at too low temperature. So, this is again concerned because if you are going to spray at too low temperatures, so then the binder is not fluid enough to come from the nozzle. So, at some part you will have a lower binder compared to the other parts in that case. So, from the nozzles it will not come up in uniform form when the viscosity of the binder is high, and there may be chances of transverse streaking also, as I may specifically when from certain nozzles spurts are coming from the especially the spray bars. So, some high pressure these jets are working, in that particular case excessive binder is coming up from some of the nozzles compared to the other nozzles, then you can have the transverse streaking also. And if transverse streaking is to a higher level or high amount of transverse streaking is there, then it can lead to the corrugations in that case, because at that moment you will have your the mix which will get softened with more amount of binder present there. Now, what can be done specifically, because here the part is these are alternate strips which forms on the pavement surface. So, one is you remove the affected surface and apply a new one, but again this is always a costly aspect which is there. So, that is why it is always said prevention is always better than cure. So, here also prevention is always. So, whenever bitumen distributors come for an application of a say tack coat or other say in case of surface dressing the bitumen application, one need to ensure that the correct quantity of binder is applied. So, that is, and correct quantity means in terms of how much quantity in a unit area is to be required, that needs to be properly controlled. So, we need to look into the temperature, we will need to look into the grade of the emulsion which has to be used for that particular application. So, when using mechanical equipment for bitumen spraying, the distributor should be properly calibrated specifically, because the nozzle, these nozzle openings also changes with time, so that also needs to be adjusted, and the speed of the binder distributor has to be properly controlled so as to have a uniform application, and operated with cure to avoid streaking. So, this is a big challenge which is there specifically. So, a proper control has to be there, otherwise the surface you need to go for to remove it, or you need to go for an application of a new course over it. Then the other surface defect which is usually experienced is a hungry surface, or we will call it as a dry surface which is there. So, if we are finding that that particular surface is lacking in the binder or the fine part of the aggregates, then what is the cause behind is the use of specifically inadequate bitumen, because usually a common practice is to save the binder, because it is a very costly component in bituminous construction. So, if less amount of binder is used than the what is designed for a particular course, then you will have these kind of hungry surfaces, and the fines will not be holded properly with the surface. So, this can, in due course of time, the fines will also get lost, and this can later on aggravate into raveling distresses also. So, if this kind of surface is there, we are finding lack of a binder is there, because this typically happens when you go for an application of a smaller quantity of binder than what is designed, or the otherwise the case may be if we are using highly absorptive aggregates, say if you are using any industrial waste, say like steel slag is there, then they are highly absorptive. So, whether that particular consideration is taken care during the design of these mixes. If that is there, then if not done, then a good amount of it may be absorbed by the aggregate itself, and the surface appears to be hungry. So, in that case, what is usually done, we can go for a fog seal or a liquid regenerating materials may be there for treatment of these hungry surfaces. So, a fog seal may be applied over these hungry surfaces, so as to meet out the requirement of the inadequate binder which is there. Slurry seal or micro surfacing can also be used as a repair option, so specifically, and the thickness is not much. We usually target for a thickness of around 2 to 4 mm when we go with slurry seals and micro surfacing, because to address the challenges related to the hungry surfaces and dry surfaces. Then the other surface defect is the hairline cracks which can be observed, and as simultaneously this usually happens when you have insufficient binder which is there, excessive filler is there, that means your mix is quite stiff. Oxidation of the surface bitumen, this surface bitumen may be oxidized because it is produced at higher temperatures at the hot mix plant, it is stored in the storage silos for higher durations. So, it gets aged, even excessively aged during the production itself, and because of, so then this binder becomes stiff, and it starts showing under the traffic loading, starts showing fine cracks. Or excessive moisture in the granular layers, if the granular layers are holding water, they are soft. So, if some overlay has been done over an existing pavement which is weak, having water in its layers, then also these fine cracks appear over the surface. So, in gradual course also, when the binder in due course of its service life will become stiff, definitely after 10-15 years of life it is going to stiff. So, during that particular course also the fine cracks may appear, but if it occurs prematurely, then it can be possible that there has been some excessive aging happened during the production itself, or the underlying surface is not providing the required support from beneath. And they may, even this may happen if these mixes are rolled when the mix is still tender, that is the mix is quite soft enough. Usually, as we discussed earlier also, that's a good amount of compaction, initial compaction is done specifically by your pavers also, where they give some vibrations to your loose mix. So, and then you start with your rolling operations. So, when you start with your rolling operations, the mix should be in such a condition that it can be compacted, otherwise it will start flowing in front of the rollers. So, that is a case of a tender mixes are there, or even when you go for over compaction also, in those particular cases also fine cracks develop into your surface. Now, important part is whenever some cracks are there, one important aspect is to immediately seal those cracks. So, if hairline cracks are observed and they are observed, so in that particular case one application is a fog seal. This is a thin application of a bituminous binder, usually emulsions are there, slow setting emulsions are there. So, there you can see, so these emulsions are getting applied over it. Many of these hairline cracks, fine cracks, even they get closed up when warm weathers are there, but otherwise it is always preferred that we seal these cracks by making an application of a fog seal, or other liquid regenerating agents may be there, and other surface treatments may be in the form of slurry seals or microsurfacing to address these hairline cracks, but they should not be left untreated. Now comes the cracking, where we discussed about different kinds of cracking in the previous lecture. We will discuss their main causes here. The load associated cracking, or the alligator cracking, or the map cracking, or the fatigue cracking, these are some of the terms which are used and are synonymous to each other. So, this is one of the common type of distresses which is usually seen on bituminous pavements, and it usually begins along the wheel paths, because those are the sections which experience maximum traffic loading, and once these cracks are there along the wheel paths, then secondary cracks start generating from them. So, this finally these secondary cracks forms these block patterns, and that is why they are known as alligator cracking also. And at an extensive stage, these materials may be picked up with the traffic, and this may lead to the formation of potholes in due course of time if not treated. So, what may be the possible causes for these alligator cracking is, one is insufficient pavement thickness is there. So, more amount of deflection will happen. So, the material will deflect to a higher level, and this will induce the tensile stresses which will be more than the strength of the material, and cracks gets initiated. Overloading of heavy commercial vehicles, as I mentioned that during the computation of the traffic, the heavy axle loads were not considered properly. The axle loads which are coming are much higher than those which were considered in computing the pavement crust thickness. Then also you will have these load associated fatigue crackings which will happen. Excessive deflections of the pavement, usually along the wheel path, because the maximum stresses comes there. So, if not properly designed, you will experience that along the wheel paths the cracks will first appear. Weakening of the subgrade or the pavement layers caused by, so if the underlying layers are weakened up specifically because of the presence of moisture, or they get saturated by water because of rise in water table, or because of improper side drainage, or because of improper subsurface drainage, then it will lead to a loss of strength and more amount of deflections will happen, and cracks will be formed mainly along the wheel path. Selection of a stiffer binder than required. So, this, because if you select a very stiff binder, then also these bituminous surfaces are prone to cracking. So, we need to ensure, as we have seen, that the binders, when we do for viscosity grading, we saw that we are ensuring for the viscosity also, which we measured at 60 degrees centigrade, and we ensured for penetration also, which we checked at 25 degrees centigrade. And when modified binders are there, again we do different testings at their low temperatures grading also, as well as for their maximum temperatures for which they are considered. So, selection, so it is important if a wrong grade, or basically for fatigue cracking to happen, if a stiffer grade is selected than what is required in that particular region, and if it gets highly oxidized, this happens. Or there may be a stripping of the underlying bituminous layers. If the stripping happens in the underlying bituminous layers, they lose their strength. So, the support gets reduced from the underlying base or binder courses, then these kind of cracks gets initiated. Now, as I mentioned, there are so many causes which are there. So, it is very important to know whether it is the inadequate thickness of the pavement which is creating a problem, or it is the presence of moisture in the underlying layers which is creating a problem, or specifically it is related to the stripping of the underlying bituminous courses which has happened. So, then the treatment has to be looked into so as that treatment can survive for a good period of time. So, since cause is often deep suited, so what the investigation usually requires in case of a strip is, you take out the cores and you look into the thickness, you look into the presence of any moisture which is there, so that you can ensure the structure adequacy, and we can go for a structure evaluation also in this particular case. Whenever any this kind of structure which has experienced fatigue cracking needs to be strengthened, then the structure evaluation in terms of either through Benkelman beam deflection study or falling wave deflection study has to be carried out, and the overlay thickness has to be computed on the basis of that structure evaluation. The repair needed is also based on the severity and extent of the cracking, how much if cracking is there in that particular case. Here it says, but important, as I mentioned, immediately whenever some cracks are observed on any particular surface, the cracks needs to be sealed up, and depending upon the severity of the cracking, because it will not happen all the sudden, leaving some specific cases that all of the sudden you will have wide cracks over your pavements. Initially the cracks will get initiated. So, if the cracks are fine enough, they can be sealed using some bitumen emulsions, or some rubberized and modified bitumen can be there. If the cracking is extensive, then we need to remove, because the material has already lost its strength. So, there is no benefit in putting up a new layer over it. Whatever the earlier existing distressed material should be removed, taken it out, and we can recycle that material using the existing recycling techniques. And as I mentioned, if this structure is not adequate enough, the structure evaluation has to be done up to compute what should be the overlay thickness is to be there to strengthen this particular one. Now, longitudinal cracks which are usually which run parallel to your center line of the road are your longitudinal cracks, and they are specifically because the joints are not properly constructed, mainly at adjacent lanes, because when you construct those lanes with the help of pavers, then the adjacent lanes are, the joints between the adjacent lanes are not properly constructed. Because of this, we usually have these longitudinal cracking. This is one of the main reasons for longitudinal cracking. So, occurs, when does it occurs? Mainly due to density gradient between the existing one and a new laid one, or between two adjacent mats which are there, when some density gradient is there. And why this density gradient comes at the joint? Because the first lane which is compacted without any lateral support. So, because there is no support, but when the second lane or the adjacent lane comes, it already have a lateral support. So, then in this particular one, its density at the edges is more compared to the first one. So, this leads to a density gradient at the joint. So, that is why this is one point where you will have lower tensile strength of your mix. So, the lower mat density is associated with the reduced tensile strength, making the joint more vulnerable towards cracking. When it gets deflected, it cracks there because the tensile strength is less at those joints of adjacent lanes. And it may also result from alternate wetting and drying beneath the shoulder, specifically because if the shoulders are constructed with inadequate materials or poor quality control has been there on shoulders, then also this wetting and drying may create these longitudinal cracks. From the weak or improper bonding between adjoining pavement layers, many a times adjoining pavement layers some widening has been done. So, that those joints are not properly constructed, then also we can experience those joints, they may show a cracks which gets reflected on the top. So, treatment depends, again it depends upon the severity and extent of longitudinal cracking, how much width, how much depth it has happened. So, low and medium severity, normally we can go for crack sealing. You can see here the crack sealing can be there, but it depends how much the width of it, as we discussed when the severity is there. Using rubberized bitumen is there, fog seal can be used for filling up those longitudinal cracks. If high severity cracking has happened, longitudinal cracking, then definitely it needs to be removed and a new fresh overlay has to be provided. So, that is another case in that. Now, transverse cracks, also known as shrinkage cracks, also known as low temperature cracks, they usually run perpendicular to the direction of the travel, and usually these cracks gets initiated at the surface and then propagate downward. So, one of the main reason is the low temperatures which are experienced by the pavement courses, and usually it is important the gradient of the temperature or the rate at which temperature falls is the one which plays a more role. If there is a sudden fall in the temperature, then the shrinkage stresses which gets developed in the mixes are more than the tensile strength. So, the mix shows these cracks, and they may be say closely spaced square ones, then it takes a shape similar to some blocks are there. So, this is again a low temperature cracking is there. So, they can be formed when surface temperatures drop enough to induce shrinkage cracks in shrinkage stresses in HMA, and then which exceeds its tensile strength. So, this transverse crack can get initiated specifically when temperatures fall, and there is a sudden fall in the temperature specifically. So, other cases may be if some say cracks are there, say the extensive cracks are there in transverse direction in the underlying layer, then also it may get reflected or it may get transverse because of the action along the those cracks. These cracks gets moved up to the surfaces also. We can call in that particular case them as reflection cracks also. A presence of excessive stiff or highly brittle and aged binder, because if that are done, they are prone to the low temperature cracking specifically. So, this is again a case when we are using stiff binder, very stiff binders, or the binders are excessively aged. So, the binders which are more susceptible to temperatures of production. So, and we can say the binders can aged because of improper production practices, or it can age because if the mat is having higher air void content than what is targeted for it. So, if the binder becomes stiff, the binder becomes harder, then under low temperatures it will show these transverse cracking. Now, transverse crack are widely repaired by sealing with liquid asphalts or other suitable materials. So, we can go for application of some fog seal or any other liquid regenerating agents which can be or the rubberized binders can be filled in these particular joints. They can also be treated with slurry seal or rubberized bitumen. This is another, depending upon what is the width of it, we can go for an application of a slurry seal also. And if this is again, if these are definitely this is the last option if these distresses grow more than a certain limit, which reduces the serviceability of the road, which reduces the ability to serve to the traffic, then we have to go for an overlay for these kind of distresses. Then the another type of cracks are the edge cracks, which are usually we can see which happens at the edges of your pavement sections. So, this is specifically happening if the edges are not properly supported. You can see if the shoulders are not properly constructed and the underlying courses near the edges, because usually heavy traffic moves along the outer lanes, and then the wheel path which is near to the outer edges may experience significantly higher stresses compared to the inner part of your carriageway. And if it is poorly constructed, having inadequate support from the shoulders, inadequate support from the underlying layers, we can see these edge cracks which usually also runs parallel to your center line. So, typically develop parallel to the pavement edge, especially where road widening. This is because widening is a very challenging exercise. How you match up the existing layers with the new construction, this is very important. And this matching is more important specifically for the drainage courses, because that plays a very important role. If the layers are not properly matched and the joints are not properly constructed, the drainage is not properly maintained, then you will have for these ones you can experience these kind of distresses, longitudinal cracking or the edge cracking happening. So, the main causes includes inadequate lateral shoulder support which is there. If shoulders are not properly, the edges are here not supported by your shoulders. Poor drainage or water accumulation on the sides are there. If side drainage is not good, the water will strand on the pavement edges, will go inside the pavement layers and will weaken those layers. So, specifically the edges where high stresses are already coming up will experience more deflections, and these cracks are going to get initiated. Accumulation, so drainage or water accumulation in even if the drains are there, then also they are not properly maintained, they are not cleaned, then water stands on those drains. Settlement of underlying layers may be there, specifically near to the pavement edges. Shrinkage of subgrade soil or insufficient pavement width at curves, usually that is another term. So, because where horizontal curves are there, we prefer to go for some extra widening. If that is not done, then we experience some heavy stresses, especially at the edges on horizontal curves if that extra winding is not provided. Inferior or thin shoulder material is provided if their shoulders are not properly maintained and constructed. Thinner bituminous surfaces at the edges, because the thickness of the bituminous surface should remain uniform throughout the width of your carriageway. It should not happen that as it goes towards the edges, the thickness typically gets reduced of your mat, then again this kind of edge cracking gets initiated, and wet subgrade always will be a problem for it. So, these are some of the typical causes for edge cracking. Then what can be done? As I mentioned, always it is important, sealing of edge cracks with suitable material. This is the first thing when these small cracks gets developed. Ensure that surface water flows to nearby drains without ponding to the pavement edges. So, shoulders needs to be properly maintained in that case, and the water from the surface water should go to your side drains. A poor draining shoulder material is replaced with permeable material. You can see if whatever your shoulder material is there, as we have seen during earlier lectures, that your drainage course needs to be extended so that it can, the water from the drainage course can be directly gone to your the side drains. So, it needs to be extended to your entire width of shoulders. So, that needs to be properly taken care, and we have to ensure that that material is not choked, your subsurface drainage layer is not choked. A poor draining shoulder material is to be replaced with a permeable material. In case of extensive cracks are there due to heavy trough loading, a structural overlay is to be designed for the entire thickness of your carriageway. Now, the other part of this particular one is under the cracking is the common one where we call it as a reflection cracking, because the one which gets reflected from the underlying layers to the top surface course. So, underlying joints or cracks which propagate through the asphalt courses, HMA overlays are there. So, if there are certain discontinuities which are there in the existing and we go for some overlay, specifically thin overlay, then those discontinuities or joints or cracks gets reflected on the overlay also. So, joints or cracks in an underlying cement concrete pavement, if that is overlaid by HMA, this can happen. These cracks can get propagated on this top surface. Cracks in soil cement base courses, specifically when stabilized courses are used over which bituminous courses are constructed, their cracks gets reflected when thin overlays are there. Cracks in existing asphalt layers, even an existing pavement which is there where extensive crackings are there, say fatigue cracking is there. If that is extensive fatigue cracking, if it is overlaid by a thin HMA, then those cracks in due course of time will get propagated to the surface. So, then the overlay, if it is not adequately designed or properly designed, so then those alligator crackings or fatigue crackings in due course of time, so then it means it is not an engineered overlay, it is not a properly designed overlay. We have just gone for a thin overlay, but it is not able to address the main cause of your inadequate structure strength. So, crack is initiated by the action in the underlying layers, whatever action, expansion, contraction which happens, those particular one gets propagated on the top surface, because these actions produces stress in the HMA layers which exceeds its tensile strength and the top surface or the overlay gets cracked. So, what can be done is in this one, if we are experiencing that the structure is sound enough, then in that case the cracks can be filled with low viscosity bituminous binder. So, if we are finding that the structure adequacy is good enough, the thickness which is crust thickness is good enough, this has happened because a structure overlay or say a concrete pavement is there, then what you can do is you can fill up those ones with low viscosity bituminous binder, and a light sand can be applied, specifically heated sand is applied to prevent binder which can be picked up, otherwise when the traffic moves over it, the binder may get picked up. If there is an extensive reflection cracking is there, that means the overlay is not properly designed. In that particular case, what we can do, we will go for the design of the overlay, and preferably it is good to provide a stress absorbing membrane interlayer, or we can go for a geotextile geocomposite which can serve both the purposes. It can add to the structure strength, the flux strength of the one, as well as it can, if it is a combination of say geotextile and geonet, whatever water which is there from the underlying layers can be taken out from the those geocomposites geonet, and so it will add to the structure strength also if we go for an application for a geocomposite. And this stress absorbing membrane interlayer, which is specifically elastomeric modified binder which is applied, this will seal what the existing cracks and will not allow water to it will make your surface overlay resistance, will create a barrier between the overlay and the existing cracks. So, these are some typical cases specifically for reflection cracking. So, this is all for today's talk. In next lecture, we will discuss about the disintegration and the possible causes of disintegration, deformation and their treatments. Thank you so much.